Welcome to this WACE Academy online lesson on gravitational force. This is the very first of the WACE Year 12 Physics course and will cover syllabus points 1 and 2 from the subtopic Gravity and Motion. Just having a quick look at these points, we can see we're going to be introduced to the idea of gravity and then begin to do some calculations. So to begin this lesson, we'll have a quick refresher on forces. Then we'll move on to gravity itself and begin to look at it as a force instead of just some ambiguous thing that keeps us on the ground. Thirdly, we'll finish with Newton's law of universal gravitation and its accompanying equation. Don't stress because of the equation, by the end of the lesson you'll have a much stronger grasp of it. Right, let's get to it. A force is something that causes a change in motion of an object. So some pretty easy examples, something like hitting a ball, pushing some books off a shelf, or dropping a fresh new iPhone on the floor and the screen shattering into a million pieces. Sorry about that. Some of you may have a neat little equation popping into your head right about now. F is equal to ma. This describes a force to be the size or magnitude as a product of the mass multiplied by the acceleration of the object. For example, the force needed to accelerate a 1 kilo object by 5 meters per second would be 5 newtons, 5 times 1. Now on to the next part of the lesson, gravity. So to begin, I'm actually going to show you the syllabus point because I think it's pretty important. All objects with mass attract one another with a gravitational force. The magnitude of this force can be calculated using Newton's law of universal gravitation. So you really need to understand and memorize this. All objects with mass attract one another. So this includes literally every single piece of matter ever to exist. But now we know that, there are a couple of other things we need to think about. If you're gravitationally attracted to every single other atom, then why aren't you ripped apart in every direction? What makes you more attracted to the Earth, or downwards, than to, say, a tree? Well, the reason for it is that the level of attraction, or magnitude of the force between various objects are different, and it actually depends upon a few different variables. Have a quick think yourself about the different variables that can increase or decrease the magnitude of gravitational force between two objects. Okay, spoiler alert, the answer is the mass of each object involved and the distance between them. Let's bring up that fancy law and equation we mentioned before. Newton's universal law of gravitation states that a particle attracts every other particle in the universe using a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Don't worry if you didn't get this the first time, because we can simply put it into an equation. Specifically, the gravitational force between two objects is equal to the gravitational constant multiplied by the two masses of each object divided by the distance between their two centers of gravity squared. The units for these variables are listed here. You'll need to know how to use this equation for your exam, so let's do an example. Find the gravitational force of attraction between a 60 kilogram woman and a 300 kilogram tree 5 meters away. So to begin this, I'd write out the variables that we do know. The woman's mass is 60 kilos, the tree's is 300, and the distance between them is 5 meters. The gravitational constant, you'll get given this by the way in exams, is 6.67408 times by 10 to the negative 11. All we need to do now is plug them into the equation and we're set. This gives a result of 4.80 times by 10 to the negative 8 newtons. We've nearly come to the end of the lesson, and we're actually going to finish with the first syllabus point. The movement of free-falling bodies in Earth's gravitational field is predictable. Let's break it down first before we do anything else. So the main ideas here are free-falling and predictable, obviously apart from gravitational field too. When it says free-falling, what it actually means is that there is only one main force acting on the object, and that's gravity. Therefore, because there are no forces opposing the pull of gravity, the object will be in free fall until it hits the ground. And when we say predictable, it means a similar path is followed by all objects when launched or dropped into free fall, that being a parabolic curve. Think about every time you've ever thrown something upwards. It begins increasing in height until reaching its maximum height, where it then begins its descent. This idea is covered more in depth in projectile motion. Alright, that brings us to the end of the lesson. I hope you've got a sturdy grasp on what gravitational attraction is. To master this topic, I can't encourage you enough to do a whole lot of practice calculation questions using Newton's universal law of gravitation. See you next lesson, guys.